Question number 10 says, AI says, calculate the matrix product, that matrix times that matrix. Guys, when someone asks for the matrix product, they're asking you to multiply. Product is the answer you get when you multiply. So if somebody says, calculate the matrix product, they're asking you to multiply the two matrices. Now, when you multiply two matrices, you multiply the rows of the first matrix by the columns in the second matrix. So we're going to multiply row by columns. Now, every time you multiply a row by a column, you get an element in the answer. This is a 2 by 2 by a 2 by 3. You're going to get another 2 by 3. Every time you multiply a row by a column, you're going to get an element in the answer. If I multiply the top row by the left column, I'm going to get the top left answer. First element in the row, first element in the column, second element in the row by the second element in the column. That's how you multiply row by column. So it's going to be 5 times 2, which is 10, and then 4 times 0, which is what? 0. So it's top row, left column. Now top row, middle column, 5 times 1 is 5, and 4 times 3 is 12. Top row, right column, 5 times minus 4 is minus 20, and 4 times 6 is 24. I just multiplied the top row by all 3 columns. Now I'm going to multiply the bottom row by all 3 columns. Minus 3 times 2 is minus 6. Minus 2 times 0 is 0. Minus 3 times 1 is minus 3. Minus 2 times 3 is minus 6. Minus 3 times minus 4 is positive 12. Minus 2 times 6 is minus 12. So it looks like our final answer here is 10, 17, 4, minus 6, minus 9, and 0. All right, let's check in. All right, I have a different answer over here, so let me just check if I made a mistake somewhere. 5 times naught is minus 20. Yeah, 5 times 4 minus 20. Yep, looks correct to me. All right, state why the two matrices in AI are compatible. Now, the first matrix is a 2 by 2 matrix. That's the order, and you are multiplying that by a 2 by 3 matrix. Now, so I'm multiplying a 2 by 2 matrix by a 2 by 3 matrix. This is the order, and the order is the number of rows by the number of columns. The number of rows by the number of columns. Now, this is what makes the two matrices compatible. So the two matrices they're compatible for multiplication because the number of columns in the first matrix is equal to the number of rows in the second matrix. So two matrices are compatible for multiplication or conformable for multiplication when the number of columns in the first is equal to the number of rows in the second. This makes them compatible. This makes them compatible for multiplication. And this is the order of the resulting matrix. The resulting matrix would be another 2 by 3 matrix. Here we're asked to determine the inverse of this matrix. Let's call it the matrix A. You didn't have to do that. Now A inverse is equal to 1 over the determinant of A times adjoint A. Now the determinant of A would be 5 times minus 2 minus 4 times minus 3. So this is minus 10 plus 12. This is positive 2. The determinant is 2. So A inverse is 1 over the determinant 2 times adjoint A. Now to get the adjoint matrix, you're going to what? Switch around the leading diagonal elements. That's the 5 and the minus 2. You switch those around. Now the other two elements stay where they are, but their signs change to minus 4 and positive 3. So therefore, A inverse is equal to, now multiplying by a half is the same as saying divide by 2. So it's minus 2 over 2, minus 4 over 2, 3 over 2, 5 over 2. The inverse is minus 1, minus 2, 3 over 2, 5 over 2. That's the inverse of the matrix that we have there. All right, the last part of the question, C. This is a question on vectors. It says the diagram below shows triangle OAB, in which OA, the position vector OA is R, the position vector OB is S. In addition, E is the midpoint of CD, and OC is 3/4 of OA. So this is 3/4, and so this must be the other quarter. And AD is 2/3, so this is 2/3 of AB. This must be 1/3. We're asked to write in terms of R and S, the simplest form, in the simplest form, an expression for CD. Now using the triangle of vectors, CD is CA plus AD. CA plus AD, that's triangle of vectors. All right, we have CA, but we don't have AD. AD, we need, first in order to get AD, I need AB. AB, triangle of vectors, is AO plus OB. Now OA is R, so AO is minus R, plus OB, which is S. Put in the positive first, this is S minus R. Now AD is 2/3 of AB. So it means therefore that CA is 1/4 of OA, and AD is 2/3 of AB. So this is 1/4 of R plus 2/3 of S minus R. We're asked to write this in its simplest form. Let's get the LCM, which is 12. 4 into 12 is 3. 3 times R is 3R. 3 into 12 is 4. 4 times 2 is 8. Simplify, we have 3R plus 8S minus 8R over 12. This is equal to 1/12 of 8S minus 5R. It's 1/12 of 8S minus 5R in its simplest form. We're asked for OE. We're asked for OE. All right, OE is this vector here. Now, using a triangular vector, OE is equal to OC plus CE. This is equal to OC plus CE, triangular vector. OC is 3/4 of R, and CE is a half of CD. So this is a half of CD, which is what? 1/12 of what? 8S minus 5R. We're asked to write this in its simplest form. This is 3/4R. This is 1/24. 8S minus 5R. The LCM is 24. 4 into this is 6. 6 times 3 is 18R plus 24 into 24 is 1. 1 times 8S minus 5R. So this is equal to 1/24 times 13R plus 8S. All right, why couldn't that be the end of it? I know I'm tired. Ooh, more. We're told that the points O, Q, and R have the coordinates 0, 0, 5, 2, -1, 4, respectively. We're to write OR as a column vector. That's not hard. In moving from O to R, I had to go 2 units to the left, 1, 2, and 1, 2, 3, 4, 5, 6, 7, 8 units up. So OR, the position vector OR is -2, 8 as a column vector. Next, we're asked for determine the magnitude of QR. So let's first get QR as a column vector. We can do it by inspection. QR, to get from Q to R, I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1, 2, 3, 4 units up. So it is -12, 4 as a column vector. Now the magnitude of QR would be the square root of -12 square plus 4 square. This is the square root of 144 plus 16. This is the square root of 140, looks like. No, 160. All right, did I do something wrong? QR. Oh, God of covenant. When you're tired and don't have anybody to say make a mistake. This is actually 1, 4. R is the point -1, 4. So the position vector OR is -1, 4. Q is actually not 6, 2. It's not 12 because it's 2 for 1. So it's actually -6, 2. It's -6, -6, 2. Let's go back again. Let's double check QR. QR. You have to go, you go back 6 and go up 2, yes. So it's minus 6.2. So it's minus 6.2. So it's minus 6 square plus 2 square. This is 36 plus 4. This is the square root of 40. And the square root of 40, I don't know. Let's just write it as the square root of 40 units.